Okay, so we're not going to waste time on introductions except to say that Heather is a program manager in the electronics department and is moderating chat here. And I am the navigator in the electronics department. And we're here to talk about the Mechatronics program. And you will have access to these slides later. So today, what we want to cover, or what we want to make sure that you leave here understanding, is what is mechatronics and why might I consider mechatronics training? What will I learn in this program and how will I learn it? We'll talk about instructional modes. Is there any internship opportunity here? And how is this relevant to the workforce? We'll talk employment sectors and jobs. Who do I contact to learn more? And right on to what is mechatronics. So mechatronics is not a new field. The term has been around for decades. It's originally, you'll see I broke it into mecha and tronics because originally this word or this term came from the combining of two words, mechanics and electronics. It is an interdisciplinary field by definition. So it combines knowledge in several subfields. So generally, we're talking electronics, mechanics, robotics, industrial automation, and control systems. We use this term sometimes, industrial automation and training, or excuse me, industrial automation training. So despite it not being a new field, I would describe it as an emergent field certainly in our region of the country, because it is relatively new here. We have had this program here at North for about 5 years now. This is great preparation for kind of a systems thinking approach to learning, where you're taking a holistic view, you're understanding better how does each part relate to another and affect kind of the whole system. It is the basic entry requirements. We have math, English, and we want some computer experience. I'm happy to share more details about the math placement, but basically we want to see that you are prepared for algebra. We have a college placement test, or we have an electronics department placement test, or if you're coming straight out of high school, you may have taken a class that shows you meet the placement requirement. Students eventually, for all certificates and degrees, need to complete English 101, but we want to see that you place into English 98 to get started. And this is a unique program indeed, because it does require that students attend North Seattle College and Shoreline Community College, not generally both at the same time. Usually you're doing all the courses you can complete at North, and then you're moving on to Shoreline to complete the remaining courses. Let's go right into this video. Is specific to mechatronics. It's less than 5 minutes. This was created by a consortium of several area colleges. We're working together on a federal tech hire grant to build out mechatronics training programs.
Silence, please. I've got students that they're driven for this. They see the outcome.
The whole idea of manufacturing to me is appealing, just being able to make things with my hands. I just know that after this, I definitely have a broader experience.
I truly do feel empowered with the skills that have been given to me.
We're not training you just to go work on a line somewhere. We're training you to think on your own.
They have a passion to make sure that you get this.
This is it. I found what I want to do in life.
I was amazed how well organized it is and how hands-on.
The mechatronics people are really going to be involved in all aspects of automation, be it manufacturing or anything else that comes up in the future.
Mechatronics is teaching our students the basics on how this all works. They'll have a better understanding going in.
People who not only could integrate the factory, they could look at a problem and trace it all the way through and fix it.
Specifically, I teach the PLC programming class and a controls and instrumentation class.
Precision measurement, blueprint reading, geometric dimensioning and tolerancing, or otherwise known as GD&T.
DC, AC, digital circuits, soldering, robotics, industrial robotics, fiber optics,
Mechanical maintenance, electronics, electricity, motors, pumps,
IT essentials, industrial motor control, fluid power, alternative energy, energy generation, manufacturing.
We touch on hydraulics, we touch on pneumatics.
We've got machines that need to be like taken apart and put back together again. It's like everything that you would do in a real job.
anything that would be involved in a modern manufacturing facility. And it's not just troubleshooting and problem fixing, it's also from the ground up design, fixing.
It is a very good program. The staff touches a lot of bases on what you need to know.
I like it all. I like it all, being able to create things and work with your hands and use your mind.
It's very fun. It's kind of challenging, but it gives you back that joy of things that you are accomplishing and that actually work. I really enjoyed this class a lot. It opened my eyes to different job professions that I would just really enjoy. I can definitely say that I enjoyed the industrial applications of robotics.
I think any woman that might be intimidated to try mechatronics, they should give it a try.
I think the field is very underrepresented by women. It ought to be 50-50 at the very least. Some of the best students have been women. More and more shops are entering into this automation world, and they're going to need more and more people. The projection is a fair number of jobs.
There is such a shortage right now of qualified people who know how to fix machines, and especially our area. In the industry.
I have friends who work at Boeing, friends who work in food processing facilities, friends who work in defense support manufacturing, friends who are just welders at a small shop in some guy's garage. You know, from this program, you can really go anywhere that has to do with the assembly of electrical or mechanical things in general.
As he goes into biomed, or if I go into mechatronics, there's automation is going to control it. Most of what we do.
Employers are not even waiting for students to finish their degree. Like, you have aptitude and interest in this, come work for us.
Actually, most of my students who've gone through the AA program have jobs before they even finish.
They are happy looking students. There is no question that the feedback that I get is overwhelmingly positive.
I would say to anybody thinking about this, absolutely do it. See what kind of help they can give you. There's money available, there's help available. There's always somebody who's willing to teach you how to walk through this whole program.
All right. So yeah, it's really fun to see students in that video and know where they are today, and they're off, you know, practicing what they've learned and working in industry. So I want to take a moment now and have you, you know, think about the workplace 20 years from now. So maybe bring to mind a job that is something you think people get paid to do, and imagine the activities that occupy your time performing that job. So when you think about some of the core tasks commonly involved in many kinds of work, here's some examples. So maybe greeting customers, or retrieving information, doing research, building presentations, supervising, coordinating with a variety of folks, answering questions, processing sales or transactions, planning how to optimize resources, making those creative decisions. Then there's, of course, the social emotional piece of things. So just kind of bring this to mind for a moment, and then I'll have you put it aside and we'll come back to it. And in the interest of time, I'm not going to give you more time to think about that right now. So just put that in the back of your mind. So I want to share some of the kind of big picture changes underway in the economy that really pertain to mechatronics as a field of study, and some of the factors that make mechatronics relevant and show why there is a need, and perhaps this will influence your career training interests. There is a re-engineering of the economy for automation that's been underway for a while. We know that, in providing products and services in our culture, we value these things. We value speed and safety and precision and efficiency. And so automation technology and robotics is it's increasingly a big deal. We see increasingly complex systems involved in various workplaces or sectors of the workplace. We need people who are talented, who have the right skills to manage all of these changes. Mechatronics in particular, this is where you're looking at navigating kind of across these disciplines, right? We talked about this being a cross-training degree. So you're learning robotics and you're doing electronics and you're doing some computer control systems. It's a variety of systems where you need to be knowledgeable. Great opportunity to collaborate with people from different fields, different areas of specialization. And most of our students really enjoy working with their hands. They are hands-on oriented. So that's an important piece of all of our programs in the electronics department. The common goal all of our students seem to share, which seems to resonate for most folks, is that we all want a career that allows us to do the work that we enjoy, and we want to make money doing it, right? So really fascinating study. There's this group called the McKinsey Global Institute, and they do a lot of, they're a think tank, and they do research on the labor market and the impact of technology and innovation. And they did this study, and it was published in 2017. They broke down 800 different occupations, different jobs globally. And they took those jobs, they broke those down into about more than 2,000, close to 2,000 different work activities. And they did this so they could look at the potential for automating these different things that we spend our time doing, these activities. And this was based on the technology at that time. So, and then they broke those activities down into different types of capabilities, like language processing and physical abilities and cognitive abilities. And I want to share just a few of their findings. One is almost 50%, so 49% of activities that people are paid to do have the potential to be automated. And that was based on current technology at that time. Also found that only a small portion of jobs could be totally automated or were totally robot proof. And also about 60%, so more than half of occupations had roughly 30% of activities that could be automated. So I think if you think back to that job, if you had an opportunity to pull up a job a few minutes ago, I bring something to mind. Really important to think about how advancing technology will impact that kind of work, or any kind of work that you would like to do when you're thinking about college and career and what you want to train for. Because the way we're doing our work now is changing, and if you've got 30 years ahead of you in your career, you want to be thinking about that. There's a really interesting survey. I put a link at the bottom of this page, just this little quiz on types of work most susceptible to automation. And if you are the person that knows how to run the robots, that's a great way to robot-proof your employment. So what do you learn in this program? If we had to distill it down to one statement, it would be you're learning skills that allow you to install, maintain, and troubleshoot these complex integrated mechatronic systems. What courses are going to address are things like electrical and electronic equipment, mechanical equipment, predictive and preventive maintenance. You're going to work with robotics, so small activity bots that you'll program and build those through larger robotic arms, a variety of sensors, some basic soldering, blueprint reading, schematics, and safety embedded throughout the program. We've also got fluid power, that's hydraulics, pneumatics, power generation and conversion, working with precise motor controls, and more. Some photos taken from our lab. So at North, labs and lectures take place in the same building. So if you have a class that, say your class meets on Monday and Wednesday, and your first hour and 20 minutes might be lecture time in the classroom, and then your next hour and 50 minutes or so generally would be move into a lab and apply what you've been learning. So upper left-hand corner, you see that's the smaller side of our main electronics lab, and each station is set up with multimeter power supply, oscilloscope. You see a robotic arm in the center at the top here. That's a sort of a picker sorter robot. On the right upper corner, we've got that's a image of a hydraulics pneumatics trainer. Lower right corner, we've got an image of a motor in our industrial power lab. And over in the lower left-hand corner, we've got our PLC trainers. So a lot of lab space and pretty amazing equipment. And for your courses at Shoreline, you'll be working in Shoreline's large shop space, and they're actually going to be rebuilding their manufacturing building quite soon. So this is the busy slide. I want you just to see how this coursework, how this partnership works. So we've got all of these courses on the left, the technical courses that fit into what we call the Industrial Automation and Electronic Control Certificate at North Seattle College. Then on the right, Shoreline Community College, we see this certificate entitled Industrial Maintenance, Robotics, and Manufacturing. And that's all of the coursework required at Shoreline. And then at the bottom, you see gen ed requirements for degrees. So whenever we're talking about an associate degree, we're going to see English 101. We're going to see human relations, U.S. cultures, global studies, courses like that. So about 15 credits that are considered general education. So to sum it up, I think next slide, there we go, recap of this kind of shared degree program, because it is very uncommon. It's two colleges, we're about 5 miles apart, we're on the Metro bus line. You complete a certificate at North, it's focused on electronics. And you complete a certificate at Shoreline, and that's a machine maintenance focus. There are a couple of classes that could be taken at either campus, and your gen ed classes could be taken at either campus. So a student who starts at North would ultimately have 29 credits that needed to be completed still at Shoreline. Those certificates stack, they form the associate degree, and then you apply for your degree from one of the two colleges. It's the same degree, essentially two different colleges, and they're named slightly differently. We call ours an Applied Associate of Science, and there's an Applied Associate of Arts and Sciences. And the pathway, so how long does it take? Again, it's variable depending on, are you full-time, are you part-time, which quarter do you start? But to try and quantify it, full-time can be completed in 7 quarters. Full-time means 3 classes. Most of our classes are 15 credits. So generally full-time student at North is taking 3 classes, 15 credits. Summer quarter, they're usually taking fewer credits because it's a shorter quarter. It's only 8 weeks long. Part-time student might take 2.5, might take 3 years to finish. It just really depends on their pace. You can start any quarter. We encourage a fall, winter, or spring start. Starting in those quarters allows students to begin with our math that is contextualized for electronics, as well as DC electronics. Those are 2 courses that are going to be required for later courses. They also happen to be 2 of our courses that have 2 instructors, which is fantastic for all students. You can start in the summer if you like as well. In that case, we would have you probably start with looking at the general education requirements, but you can work with me. I am glad to help you build a plan that suits your needs and aligns with when courses are offered. This is not a transfer degree, but a little tip: when you see courses like English ampersand 101 and you see that ampersand symbol, that's a good indication that this is a transferable course. So again, our program is really designed for entrance into the workplace. Teaching and learning, what does it look like? What's our model look like? Well, faculty from industry, we have full-time faculty, we have adjunct faculty as well who are working in this industry, but they come in to teach a class. You've got the expertise of faculty from 2 different colleges. So each college gets to do what we do best. We get to focus on electronics at North and the machine maintenance side of things at Shoreline. We are hands-on applied, so learn by doing. We hire students who have gone through our classes and our programs, and we hire them as paid teaching or lab assistants. So it's additional support for students. It's also a job for our students that they can put on their resume. Peer students or students come to us with a really broad range of backgrounds, from straight out of high school, career changers. We occasionally have engineers who really need this. They've got a lot of theory and they don't have the hands-on application experience. We have industry guests who come in and they share their expertise and talk about the work that they do and give you indication of opportunities in their specific industries. We have opportunity to make the classes more personally relevant to you. Say your industrial robotics final project I mentioned in the last session. That's my favorite, to observe and see what students do, from teaching the robot to make coffee, which you saw a glimpse of in the video, to teaching it to draw in the round as if like doing an arm tattoo, to draw a complex geometric pattern, or teaching a robot to play a keyboard, a variety of things. And you might, in a class, you may interview somebody doing the kind of work that you would like to be doing. Internship is a piece of the Mechatronics program, and I will dig into that here. It is a 4-credit internship that we encourage students to pursue. We provide support, although students do apply for their own internship. This is a practical work-based opportunity, and so we definitely encourage students to do this. This is your opportunity to try on a particular employer. If a student chooses not to do an internship, or they prefer to take more classes, we have that option. A student could choose 2 classes from this list of 5. So maybe you want to get into study some fiber optics, or go further with IT to get your A+ certification. You could take a class there. Or AC is something that you're going to touch on a little bit in some of your electronics, or in another of your electronics classes, but you won't dig in deep. So maybe that's a class you want to take, or more digital electronics. So we've got some flexibility there. And many of our students complete a summer internship with Boeing, and that's been a great experience for all of our students. Some go on to work for Boeing, some go on to work for other employers. And I know I'm talking kind of quickly, and I see we have about 7 minutes to go, and I learned from the last session to kind of keep the pace. But maybe this is a quick opportunity before we get into like where in the workplace we're seeing mechatronics opportunities, to see, are there any questions we want to address? Heather, is there anything we should bring up right now?
There's nothing in the chat that needs to be addressed.
Okay.
But I think that, Julie, you've been doing a really great job of giving an overview of that kind of multiple disciplines all coming together. And, it's been really great to see the students and their projects in particular. I know that you mentioned the industrial robotics class just being a really great opportunity to see a creative spark that sometimes you don't end up getting to see in some of the other classes, because they're a little bit more math based. It's the science of physics and electronics. So it's been a lot of fun to see the students' creativity. But if anybody has any questions, feel free to chime into the chat or raise your hand. Otherwise, we might just keep moving so we don't run out of time.
Yeah. So let's talk about where we see mechatronics, in the workforce. And there really aren't many industries where mechatronics training is not relevant at this point. So most employment sectors, we're going to see demand. And keep in mind that there are positions that will come into existence, or jobs over the next 5 and 10 years that really don't exist yet at this point. But advanced manufacturing, and when I say advanced manufacturing, I'm really just talking about those industries and employers that are using technology to improve, or innovative technology to improve product design and production processes. We've got automotive, transportation, logistics. Logistics, I'm referring to the flow of goods. Think about Amazon and how far and wide things have to be sorted and delivered. Biotech, life sciences, medical equipment, healthcare, aerospace, aviation, space exploration, renewable energy, chemical and materials processing, agriculture, food, forestry, smart home and personal technologies. And so kind of everywhere, but jobs now, and jobs that are increasingly in demand as we move forward. And when we talk about job titles, so really in our market today, the job titles that you're going to see are going to reflect those subfields of mechatronics rather than the combined interdisciplinary knowledge of mechatronics. So, you know, as I may have mentioned, this might have been the prior session, we're a relatively new degree. We're about 5 years into offering this training because it was really a lack of mechatronics training in our region of the country. So more of an emergent field. So it does follow that employers aren't recognizing that they can find this, you know, diverse integrated skill set in one candidate. Now, Boeing is an example of an employer that does utilize mechatronics. They adopted that job title in about 2017. So they're actively using that. But if we look at some of the job titles that are well aligned with the mechatronics trained candidate, we've got industrial maintenance technician, electronics technician, electromechanical technician, field service, robotics technicians, automation, control systems, industrial mechanic. This is a sampling of those jobs. And you may have noticed one thing in common, this word technician. And when I say technician, I'm referring to the individual that has really proficient knowledge and skills in their area of expertise, but they've also got this practical understanding of theory. So typically this is someone who has had applied experience, commonly an associate degree completer. So our focus is this technician training. So let's look at employers. So where are some of our students landing? There were several from actually the video we watched a little earlier who I think are reflected in some of these examples. So about a dozen employers have listed here. Got a little carried away and thought, you know, we don't know what all of these folks do. So I wanted to add a little description of what they're doing. You know, many of these you've probably heard of, some perhaps not. I mean, directed machines, one of the students in the video has a really fascinating job. I wasn't familiar with directed machines, but they're doing solar powered land care robots. You might be familiar with outdoor research as their, you know, outdoor gear and apparel. And when pandemic struck, they retooled and they started up. They've got a factory where they're manufacturing PPE, the protective gear for the medical industry. Sinrad, they're a laser manufacturer. So welcome to look back at this and this is just an example of where mechatronics students tend to have gone. Employment outlook. So we all want to know, is there money in this? Can I earn a sustainable living and make a fair wage? And it is fair to say that our students in mechatronics and really all of our degrees within the electronics department, starting at a pay rate of a minimum of about $24 an hour and on up from there. So if we look at two job titles that are right in the wheelhouse of the mechatronics skill set, I've got industrial machinery mechanic and I've got electromechanical technician. And when you look at, yeah.
Just so you know, it's going to close in like 20 seconds.
20 seconds?
Yeah.
Okay, 20 seconds. So you're going to look back at this because this is really good stuff. Oh, we're right at the end, frequently asked questions. So you'll have an opportunity to look at that. But here's contact information. So feel welcome to reach out.
Welcome back, everyone.
Thank you all. Welcome back. All right. Well, I just want to take a moment to thank all the students and prospective students that came to join us today. We hope that you got a real good chance to ask questions, learn about these different options there, and you know, really your next steps as you transition is to really reflect and start thinking about seeing yourself in these really cool careers that we have laid before you. Hopefully you also got some good contacts to people who are passionate and really really just sharing the love of their fields with you. And so as you continue through your journey, we hope that this isn't the last time we see you. We got a couple next steps that we definitely want you to think about. So one of the major things is definitely we want to get your feedback. So we're going to ask that you take a moment before you leave today to do a survey and just tell us about what you learned, you know, if there's things we could improve upon, and how we could improve for the next time we start to offer these. So that will be here in the link now. So definitely check out the link. Some other things that we want you to think about if you are ready to go and you know, the Seattle colleges are going to be your next step. One of the first things you can do is complete your admissions application. It's free. And then from there, you'll get some additional information on helping you move through the next steps of enrollment. We'd also suggest that you connect with your advisors. This could also be your counselors at the high schools. But as you're transitioning and you're trying to line up all of those resources you're going to need to finish your enrollment steps and just kind of get there, utilize the wonderful resources in your career center. And step 4 is, again, keep exploring, start doing that reflection, see what it is that really excites you about all these different industries that you heard about today. And one thing I can say is it never stops. As you continue and you get into your fields, you know, you're going to be building a lot of great knowledge and skills, and you're going to be reflecting when you're there too. And so we really want you to get a lot out of this and just continue that journey as you move on. So huge thank you. Let's give a round of applause to all of our presenters today, all of our faculty members, not just for today, but for all that you do for our students every day. Thank you so much for joining us for this really cool event. And I'm excited to see how this evolves as time goes on. So any parting words that any of our faculty or staff would like to say before we wrap up? All right. Well, thank you again. Yes, please do fill out that survey that's in the link. Before you go, let us know what your thoughts are, and just thank you. Thank you very much for joining us today. Remember, there are more sessions happening tomorrow that you can join in on if you're still exploring as well. So it's tomorrow, social sciences, humanities, and language. And so you have a chance to continue your research. All right, thank you.